Alright, here we go with the last of the new topics for Calc BC, arc length and polar form. I want to draw your attention to the parametric form of arc length, and that's going to be L equals to the integral from a to b of the square root of dx dt squared plus dy dt squared dt. We're going to convert this over into polar form. So since we have some r as a function of theta, we know that x equals to r cosine theta, so we can also say that x equals to f of theta cosine theta. Similarly, r equals to sine theta. So if I were to rewrite this in polar form, I would have L equals to, instead of using a and b, I'm going to go ahead and use alpha and beta. So dx dt is going to be dr d theta times cosine theta minus r sine theta quantity squared. This is my dx dt. Then I'm going to add to that dy dt, which happens to be dr d theta times sine theta plus r cosine theta. Now I need to FOIL this out and simplify. Okay, when we FOIL out this first part, we have dr d theta squared cosine squared theta minus 2r dr d theta cosine theta sine theta plus r squared sine squared theta. In the second part, we have dr d theta squared sine squared plus 2r dr d theta sine theta cosine theta plus r squared cosine squared theta d theta. Now a few things are going to happen here. You're going to notice these two will cancel, and we're going to pair up and simplify these two and pair up and simplify these two. So we're going to end up with dr d theta quantity squared plus r squared d theta. This is our arc length formula in polar form. Now before doing an example, I'm going to go ahead and just tie this into surface area in polar form. So when we have a surface area revolved around y, it's going to be 2 pi times the radius, but our radius here will be in terms of x, and x equals to r cosine theta. And then we have our arc length, dr d theta squared plus r squared. And then we have surface area in terms of x from gamma to delta, and the radius is going to be in terms of y, so we're going to have our sine theta here, and then our arc length formula, dr d theta squared plus r squared. And now we'll do two examples. So our first one, find the arc length of the entire cardioid, r equals to 2 minus 2 cosine theta. Now this particular cardioid is symmetric top and bottom, so across the polar axis. And when theta equals to 0, cosine 0 is 1, so I know it starts at the pole. Now for arc length, because the theta interval is 2 pi, and this goes from 0 to 2 pi, we cannot plug in our integral to go from 0 to 2 pi, because those start and end at the same place, and they're just going to cancel each other out. So what we have to do here is double the integral from 0 to 2 pi, and then work out our arc length formula. So I need to plug in dr d theta, which happens to be 2 sine theta, and r squared is 2 minus 2 cosine theta squared. So simplifying this integral, we have 4 sine squared theta plus 4 minus 8 cosine theta plus 4 cosine squared theta d theta. We're going to go ahead and put these two together, which is going to add up to equal 4, and then we're going to have 8 minus 8 cosine theta left over. I'm going to pull out my constant 8, and I have 1 minus cosine theta. This is actually going to use the half angle formula, which comes from the double angle formula for cosines. So let me just show you and remind you over here on the side. Remember, our double angle formula for cosine is 1 minus 2 sine squared theta. So 2 sine squared theta equals to 1 minus cosine 2 theta. Now notice this is cosine theta, and I have a cosine 2 theta over here. So if I rewrite this as 1 minus cosine theta, I'm now going to have 2 sine squared theta over 2. That's going to be my substitution. So rewriting my integral, I have the square root of 2 sine squared theta over 2 d theta. I'm going to get 8 times the integral of sine theta over 2 d theta. We can now integrate this pretty easily. I get negative 16 cosine theta over 2 from 0 to pi, which is negative 16 cosine pi over 2 minus cosine 0, which is equal to 16. Last example. Let's find the surface area formed by revolving r equals to cosine theta about the line theta equals pi over 2. R equals cosine theta is a circle with a theta interval of 0 to pi. We're revolving around theta equals pi over 2, which is a vertical line. So if you pick any point on your curve, your radius happens to be your x. So when we write out the surface area revolved around the y-axis, we have the integral from 0 to pi, because the theta interval for cosine theta is pi, and we're going to use 2 pi x, which we need to turn into polar form, which is r cosine theta. Then we have our arc length, which is the square root of dr d theta squared plus r squared d theta. Now let's plug in what we need. R is cosine theta, so times another cosine theta makes it squared. Dr d theta is negative sine theta, and r squared is cosine squared theta. This works out nicely. Our radical becomes a 1, so we just need to integrate a cosine squared. That's going to require our power reducing formula, 1 plus cosine 2 theta over 2. So when I integrate, I get theta plus 1/2 sine 2 theta, which gives me pi plus 1/2 sine 2 pi minus 0 plus 1/2 sine 0. And this works out to be pi squared square units. And there's our last example for all the new stuff for Calc BC.